In this lecture, we will discuss how to write an embedded C program to perform 8-bit division and 8051 microcontroller. Even if it is an embedded C program in 8051, we need some idea about the SFR memory location, because SFR memory location or the general architecture of RAM memory 00 to 7F is actually general purpose RAM, and 80 to FF is actually special function register. And we can also connect some external memory to 8051. In this particular question, it's not mentioned where the values are stored, so we'll assume that the data are stored in external RAM memory location. Okay, and we need to perform the division operation, the content of external RAM memory, and after performing the division operation, we need to store the value again in external memory. And if you look at this SFR location, I will give a more detailed picture of this SFR location. So here you can see that SFR location is also is some address. You can see that the B register address is F0, and accumulator you can see that E0, because in order to perform the division operation uh, in standard 8051 microcontroller, the div instruction is actually used. Even if you write the embedded C program, it will automatically convert that division uh, operation by using div AB. Okay, so if you perform the division operation, after the operation, the result is stored in A and B. So we need to access the B register. So that's why the address of B register we need to use. The B register address is F0. Okay, and accumulator is E0 that we can access without the address also. So assume that the two values are stored in 2000 and 2001-ish, and even if you are writing this program in embedded C, after the execution, the final result you can access from A and B. So that's why I explained some basic concept of this div AB instruction. This is assembly language program code, and after this operation, normally it will perform A by B. Okay, this A by B operation, if you perform after the operation, the accumulator, that A register will store the integer part of the result, and B register store the remainder. And one more thing is very important. There are two flags, carry flag and overflow flag, which is in PSW register, program status word register, and PSW, within the PSW, the carry flag and overflow flag will be cleared, or the CY and overflow flag will be 00 if the result is in a proper form. And we know that we cannot perform something divided by 0. That is, if B value is equal to 0, okay, then that division is invalid. To indicate that result is invalid, the overflow flag will be set. So that's again very important. After the division operation, either if you perform in embedded C or in assembly language program, after the division operation, the result will be available in A and B. And in the case of the second case, that if B is equal to 0, we cannot say that the content of A and B, that is undefined. Any value can be in A and B register, but in order to indicate the result is invalid, you can look at the overflow flag, but carry flag will be 0. In both the case, carry flag will be 0, but if overflow flag is cleared, the result is valid one, and the overflow flag is 1, it is an invalid result. Okay, we'll consider only valid results. After the result, after the division operation, the result is stored in 2002H and 2003, quotient in 2002 and remainder in 2003. Now we'll see the algorithm. We'll write simple algorithm that we'll read the content of 2000, and in actual microcontroller, that value should be copied into A, and the next value 2001 that will be copied into register B internally, and we need to perform the operation A by B. Okay, this is only possible combination A by B. It's actually performed by using div internally, but we'll write simply this simple, division symbol, but internally it is performed by using div AB. So after this operation, the quotient result is stored in accumulator. That should be loaded into 2002. Automatically it will load the quotient result, but remainder we need to store from B register. Okay, the B register address is F0. And now we can see the embedded C program. In embedded C program, we need to include the first statement hash include rich51.h. This is standard statement. We need to include on all the embedded C program related to 8051. And here you can see a statement called SFR. So this is a embedded C command not available in normal C program. SFR indicate that this is an SFR location. F0 is an F0H is actually an memory address in SFR memory location, special function register address, and we will access this SFR location F0 by using the name remainder. That's the meaning of the statement SFR space remainder is equal to 0xF0. So within the program, if you use the remainder, the name remainder, it will automatically read the content of F0. Okay. So please remember this particular statement. Whenever you want to access an SFR location, use the keyword SFR. And the main program, we will declare two pointers, num and result, by using character type, because we require only 8-bit information. So numbers are 8-bit, and the result remainder and quotient again 8-bit, 8-bit. So we'll use num and result as two pointers, and we will store the result in 2002. So we'll 2002 and 3. So we'll assign result by using the keyword 0x2002 to indicate 2000h, and num, the number first number is in 2000, so we'll assign num with 2000h. And we need to perform the operation 2000, the content of 2000 divided by content of 2001. So already num is loaded with 2000, so we'll use star num, and we need to access the content of 2001, so num plus 1, which is num plus 1, and star num plus 1, and we'll perform the division operation by using this particular symbol in C. And after this operation, the quotient will be loaded into the location, because the result is again a character type. Okay, this is the result. Result is loaded with 2002, and the quotient is already loaded. Now we need to load the remainder. Remainder is available in B register, or we can call this in F0, memory location F0. So we need to access the content of F0. So already we declared that F0 is accessed by using the name remainder. So remainder is loaded into result plus 1. That is in 2003, we will load the result. Okay, after that we'll go to the infinite loop. Now we'll see how we can execute this particular program in write C compiler. Now we can see how we can debug this program in write compiler. So the program is already built. Now we can start debugging. For that we need the X data view, and you can also see the main register. And SFR also we can see if you are interested. So first we'll take X data. In 2000, we need to store some value. For example, we'll take 8 here, and the next location will load 4. So we need to perform 8 by 4. Now we can execute the program. Okay. So after the operation, 2002 hold the quotient, that is 2, and remainder in 2003. You can also verify the result in accumulator and where in a B register after the operation. So if you reset and again if you are performing some other result, for example 6 by 3, okay, you can change the value, it will be 0 0. Okay, so if you start the operation, after the operation, if you look at the accumulator, it contains 2 and B register with 0. And if you also look at the SFR, the F0 location, F0 is loaded with 0 0. That is a remainder. We'll see another Example, let 6 by 4. Okay, I can perform the operation 6 by 4, and now we'll see what will be the output. Okay, after the operation, you can see that the accumulator contain 1, that the quotient, and remainder in B list, that is 2. It's also available in SFR view. Here also you can see F0 is loaded with 2. And now after one more operation, you can see that value is copied into 2003, 02. Okay, the quotient and remainder. Similarly, you can verify different values.